CASNB. Data Analytics. Part 1, Theory. Topic 1. Data Analytics. Data analytics is the process of examining large and varied data sets to extract insights and draw conclusions about the information they contain. It involves the use of statistical and computational methods to analyze data and identify patterns, trends, and relationships that can be used to inform business decisions. The goal of data analytics is to provide organizations with the ability to make more informed and data-driven decisions. This is achieved by collecting, processing, and analyzing data from various sources, such as customer behavior, website traffic, financial transactions, and social media interactions. Data analytics can be used in various fields such as marketing, finance, healthcare, and sports to make predictions, optimize processes, and identify areas for improvement. Common techniques used in data analytics include data mining, predictive analytics, machine learning, and statistical analysis. Data analytics is the process of examining large and varied data sets to extract insights and draw conclusions about the information they contain. It involves the use of statistical and computational methods to analyze data and identify patterns, trends, and relationships that can be used to inform business decisions. The goal of data analytics is to provide organizations with the ability to make more informed and data-driven decisions. This is achieved by collecting, processing, and analyzing data from various sources, such as customer behavior, website traffic, financial transactions, and social media interactions. Data analytics can be used in various fields such as marketing, finance, healthcare, and sports to make predictions, optimize processes, and identify areas for improvement. Common techniques used in data analytics include data mining, predictive analytics, machine learning, and statistical analysis as explained below. 1. Machine learning. Machine learning is a subset of artificial intelligence, AI, that involves developing algorithms and statistical models that enable computer systems to learn from and make predictions or decisions based on data. Machine learning involves various techniques such as supervised learning, unsupervised learning, reinforcement learning, and deep learning. It has applications in various industries such as healthcare, finance, and e-commerce. 2. Hacking skill. Hacking skills refer to the ability to identify and exploit weaknesses in computer systems or networks. It involves the use of various techniques such as social engineering, network scanning, and vulnerability assessment. Ethical hackers, also known as white hat hackers, use their hacking skills for the purpose of identifying and fixing security vulnerabilities in systems, while malicious hackers, also known as black hat hackers, use their skills for illegal activities such as stealing sensitive information. 3. Mathematics and statistics. Mathematics and statistics are important fields in data analytics and machine learning. Mathematics provides the foundation for understanding algorithms and models used in machine learning, while statistics enables data analysts to draw meaningful insights from data by providing techniques for data analysis and hypothesis testing. 4. Substantive research. Substantive research refers to research that is focused on answering specific questions or hypotheses related to a particular field or topic. It involves the collection and analysis of data to test a theory or to gain a deeper understanding of a particular phenomenon. Substantive research can be quantitative or qualitative, and it involves the use of various research methods such as surveys, experiments, and case studies. Substantive research is used in various fields such as social sciences, healthcare, and business. Here are some useful keyboard shortcuts for financial modeling in Excel. F2, Edit Cell. F4, Repeat last action. F9, Calculate all sheets in all open workbooks. F12, Save as. Ctrl+Z, Undo. Ctrl plus Y, redo. Ctrl plus B, apply bold formatting. Ctrl plus I, apply italic formatting. Ctrl plus U, apply underline formatting. Ctrl plus 1, open Format Cells dialog box. Ctrl plus, enter current date. Ctrl plus Shift plus, enter current time. Ctrl plus Shift plus $, apply currency formatting. Ctrl plus Shift plus %, apply percentage formatting. Ctrl plus Shift plus hashtag, apply date formatting. Ctrl plus Shift plus and, apply outline border. Ctrl plus Shift plus underscore, remove underline formatting. Ctrl plus Shift plus, apply general number format. Ctrl plus Shift plus $, apply accounting number format. Alt plus equals, auto sum. These shortcuts can save you a lot of time and increase your productivity when building financial models in Excel. Using advanced formulas and functions to enhance the functionality of financial models. Excel offers a variety of advanced formulas and functions that can enhance the functionality of financial models. Here are a few examples that we shall include in the practical sessions. 1. VLOOKUP and LOOKUP. These functions allow you to search for a specific value in a table and return a corresponding value in the same row or column. This can be useful for looking up interest rates or other financial data based on specific criteria. 2. SUMIF and SUMIFs. These functions allow you to sum values in a range based on certain criteria. For example, you could use SUMIF to add up all expenses in a specific category, or use SUMIFs to add up expenses in a certain category for a specific time period. 3. If functions. The if function in Excel allows you to test a condition and return one value if the condition is true, and another value if the condition is false. Here's the syntax for the if function: equals if, logical test, value if true, value if false. The logical test argument is the condition you want to test. This can be a logical expression, a comparison, or a function that returns a logical value, such as the and or functions. The value if true argument is the value that is returned if the logical test is true. The value if false argument is the value that is returned if the logical test is false. 4. NPV and ERR. These functions allow you to calculate the net present value, NPV, and internal rate of return, ERR, of a series of cash flows. This can be useful for evaluating the profitability of an investment or project. Get more examples in the practical part 2. 5. PMT. This function allows you to calculate the payment required to pay off a loan over a specific period of time, with a specific interest rate. 6. Conditional formatting. This feature allows you to format cells based on certain criteria. For example, you could highlight cells with negative values in red, or cells with values above a certain threshold in green. 7. Data validation. This feature allows you to set rules for data entry in a specific cell or range of cells. For example, you could require users to enter a number within a specific range, or select an item from a drop-down list. By using these and other advanced formulas and functions, you can create more powerful and accurate financial models in Excel. Topic 2. Introduction to Data Analytics. The C.R.I.S.P. Cross-Industry Standard Process for Data Mining framework is a well-established and widely used process model for data mining and analytics. The CRISP framework provides a structured approach to help organizations go through the entire data analytics process from start to finish, including data preparation, modeling, evaluation, and deployment. The CRISP framework consists of 6 phases, as follows. 1. Business understanding. In this phase, the problem that needs to be solved is identified and the project goals are defined. This includes understanding the business objectives, assessing the current situation, and defining the success criteria. 2. Data understanding. In this phase, data sources are identified, collected, and analyzed. This includes exploring the data to understand its characteristics, quality, and relevance to the problem at hand. 3. Data preparation. In this phase, the data is prepared for modeling by selecting and cleaning the relevant data, transforming and integrating the data, and creating the modeling dataset. 4. Modeling. In this phase, statistical and machine learning models are created to analyze the data and generate insights. This includes selecting appropriate modeling techniques, building the models, and validating them. 5. Evaluation. In this phase, the results of the models are evaluated against the success criteria defined in the first phase. This includes testing the models and assessing their accuracy, reliability, and usefulness. 6. Deployment. In this final phase, the results of the data analytics project are communicated to the stakeholders and the insights generated by the models are integrated into the business processes. This includes creating reports, developing a plan for ongoing monitoring, and preparing for future projects. The CRISP framework provides a systematic and iterative approach to data analytics, enabling organizations to generate valuable insights from their data and make informed decisions based on those insights. It is widely used in industry and academia and is a valuable tool for any organization that wants to harness the power of data analytics. Data models are used to represent the structure and relationships between data in a particular system or organization. There are 3 types of data models: conceptual, logical, and physical. 1. Conceptual data model. The conceptual data model is a high-level abstraction that represents the overall structure of data, independent of any specific technology or implementation. It provides a simplified view of the business requirements and the relationships between entities in the system. The conceptual model is usually created during the early stages of a project and is used to communicate with business stakeholders. 2. Logical data model. The logical data model is a detailed representation of the data requirements, which takes into account the business rules and constraints that apply to the data. It is independent of any specific database technology or storage mechanism. The logical model is used to document the data elements and relationships that will be required to meet the business requirements. 3. Physical data model. The physical data model is a detailed representation of the data structures, including tables, columns, indexes, and constraints, required to implement the logical data model in a specific database technology or storage mechanism. The physical model takes into account the specific requirements of the technology, such as performance and scalability, and includes details such as data types, key constraints, and indexing strategies. In summary, the conceptual data model is a high-level representation of the data requirements, the logical data model is a detailed representation of the data elements and relationships, and the physical data model is a detailed representation of the data structures required to implement the logical model in a specific technology or storage mechanism. Stages in data life cycle: identifying data sources, modeling data requirements, obtaining data, recording data, using data for making business decision, removing data. The data life cycle refers to the stages that data goes through from its creation to its disposal. The stages of the data life cycle are as follows. 1. Identifying data sources. In this stage, the sources of data are identified. This includes understanding the data that is available, where it comes from, and how it is collected. 2. Modeling data requirements. In this stage, the requirements for the data are identified and modeled. This includes understanding the data that is needed, how it will be used, and what format it needs to be in. 3. Obtaining data. In this stage, the data is obtained from the sources identified in stage 1. This may include acquiring data from internal or external sources, such as databases, file systems, or APIs. For recording data, in this stage, the data is recorded and stored in a database or other storage system. This includes ensuring that the data is properly formatted, validated, and secured. 5. Using data for making business decisions. In this stage, the data is used for making business decisions. This may include analyzing the data to gain insights, creating reports, or using the data to make decisions about future business strategies. 6. Removing data. In this stage, the data is removed from the system when it is no longer needed. This may include archiving data for future use, or securely disposing of data that is no longer required. The data life cycle is an iterative process, with each stage building upon the previous one. It is important to manage data through each stage of the life cycle to ensure that it is accurate, secure, and properly utilized for making business decisions. Topic 3. Big data and data analytics. Definition of big data. Big data refers to extremely large data sets that are so complex and varied that traditional data processing applications are unable to handle them. It is characterized by the 3 V's: volume, velocity, and variety. Volume refers to the vast amounts of data being generated every day. This includes structured data, such as transactional data from sales systems, as well as unstructured data, such as social media posts, images, and videos. Velocity refers to the speed at which data is generated and needs to be processed. With the increasing use of the Internet of Things, IoT, and other real-time systems, data is being generated at a faster rate than ever before. Variety refers to the different types of data that are generated, including structured data, unstructured data, and semi-structured data, such as XML or JSON files. In addition to the 3 V's, big data is also characterized by its veracity, accuracy and reliability, value, the insights that can be derived from the data, and complexity, the challenges involved in storing, processing, and analyzing such large data sets. Big data has become increasingly important in a wide range of industries, including finance, healthcare, marketing, and more. It requires specialized tools and technologies to manage and analyze, such as distributed computing frameworks, machine learning algorithms, and data visualization tools. We can also describe big data as follows. Big data refers to large volumes of structured and unstructured data that is generated at a high velocity and comes from a variety of sources. Big data is characterized by its volume, variety, and velocity, and requires specialized tools and technologies to manage and analyze it effectively. Data analytics, on the other hand, is the process of examining data to uncover insights and trends that can be used to inform business decisions. It involves using statistical and mathematical models to analyze data and draw conclusions from it. Data analytics can be used to identify patterns in data, forecast future trends, and identify opportunities for improvement in business processes. Big data and data analytics are closely related, as big data often requires specialized tools and techniques to analyze it effectively. Data analytics can be used to extract insights from big data, which can then be used to inform business decisions. This can be particularly valuable in industries such as finance, healthcare, and marketing, where large volumes of data are generated and can provide valuable insights into consumer behavior, market trends, and more. In summary, big data refers to the large volumes of structured and unstructured data that is generated at a high velocity and comes from a variety of sources, while data analytics is the process of examining data to uncover insights and trends that can be used to inform business decisions. Together, big data and data analytics can be used to extract valuable insights from large volumes of data, leading to improved business processes and better decision-making. The 5 V's of big data. The 5 V's of big data are: 1. Volume, refers to the vast amount of data being generated, collected, and processed. With the growth of technology and the internet, data is being generated at an unprecedented rate. 2. Velocity, refers to the speed at which data is being generated, collected, and processed. Real-time data is becoming increasingly important for many organizations, as it enables them to make faster decisions and respond to changes more quickly. 3. Variety, refers to the different types of data being generated, collected, and processed. Data can come in structured, semi-structured, and unstructured formats, such as text, images, videos, social media posts, and sensor data. 4. Veracity, refers to the reliability and accuracy of the data being generated, collected, and processed. Big data often comes from various sources and may contain errors, inconsistencies, and biases. 5. Value, refers to the usefulness and insights that can be extracted from big data. The ultimate goal of big data is to extract valuable insights that can help organizations make better decisions, improve their products and services, and drive innovation. Types of data analytics: descriptive analytics, prescriptive analytics, and predictive analytics. There are 4 main types of data analytics. 1. Descriptive analytics. This type of analytics describes what has happened in the past. It involves analyzing historical data to understand patterns, trends, and relationships between different variables. Descriptive analytics provides insights into what has happened and why. 2. Diagnostic analytics. This type of analytics helps to explain why something happened in the past. It involves analyzing data to identify the root cause of a problem or a particular outcome. Diagnostic analytics can help organizations to identify areas for improvement and make more informed decisions. 3. Predictive analytics. This type of analytics uses data, statistical algorithms, and machine learning techniques to predict future outcomes based on historical data. Predictive analytics can help organizations to anticipate future trends, identify potential risks, and make more informed decisions. 4. Prescriptive analytics. This type of analytics goes beyond predicting future outcomes and provides recommendations on what actions to take to achieve a particular outcome. It uses optimization techniques, simulation models, and decision analysis to determine the best course of action to achieve a specific goal. Each of these analytics types can be used in combination to provide a more comprehensive and insightful analysis of data. Topic 4. Tools for data analytics. There are many tools available for data analytics, and the choice of tool depends on the specific needs and goals of the organization or individual. Here are some of the most popular tools for data analytics. 1. Microsoft Excel, one of the most widely used tools for data analysis. Excel can handle large amounts of data, has built-in functions for data manipulation, and can create charts and graphs for visualization. 2. R, an open-source programming language and environment for statistical computing and graphics. R has a wide range of statistical and graphical techniques built in and allows users to develop their own custom functions. 3. Python, another popular open-source programming language that has gained significant traction in data science and analytics. Python has a vast number of libraries, including Pandas and NumPy, for data manipulation and analysis. 4. Tableau, a data visualization software that allows users to create interactive and dynamic visualizations, dashboards, and reports. Tableau can connect to a wide range of data sources and provides tools for data blending and advanced analytics. 5. SAS, a suite of software products for advanced analytics, data management, and business intelligence. SAS is widely used in industries such as healthcare, finance, and government for data analysis and modeling. 6. Apache Hadoop, an open-source framework for distributed storage and processing of large-scale data sets. Hadoop is designed to handle big data and provides tools for data processing, management, and analysis. These are just some of the many tools available for data analytics, and the choice of tool depends on the specific needs and goals of the organization or individual. Data cleaning tools, Alteryx, SSIS, DataStage, and others. There are many tools available for data cleaning and preparation. Here are some of the most popular ones. 1. Alteryx, a data preparation and analytics platform that allows users to automate data cleaning, blending, and analysis tasks. Alteryx provides a visual workflow interface that allows users to drag and drop tools to build data workflows. 2. SSIS, SQL Server Integration Services, a data integration and transformation tool provided by Microsoft SQL Server. SSIS allows users to extract, transform, and load, ETL, data from various sources and clean and transform it for analysis. 3. DataStage, an ETL tool provided by IBM that allows users to extract, transform, and load data from various sources. DataStage provides a visual interface for building data workflows and includes a range of data cleaning and transformation functions. 4. OpenRefine, an open-source tool for data cleaning and transformation. OpenRefine allows users to clean and transform data in a spreadsheet-like interface and provides a range of functions for data cleaning, standardization, and matching. 5. Trifacta, a data preparation tool that uses machine learning to help users clean and prepare data for analysis. Trifacta provides a visual interface for data cleaning and transformation and includes a range of built-in functions for common data cleaning tasks. These are just some of the many tools available for data cleaning and preparation, and the choice of tool depends on the specific needs and goals of the organization or individual. Data management, storage/DBA SQL, Oracle, cloud computing, AWS, Azure, and others. There are many tools and technologies available for data management, storage, and database administration, DBA. Here are some of the most popular ones. 1. SQL, Structured Query Language. SQL is a standard language used to manage relational databases. SQL can be used to create, modify, and delete databases, tables, and data, as well as to retrieve data from databases using queries. 2. Oracle. Oracle is a popular relational database management system, RDBMS, used by many organizations for data management. It provides a range of tools for database administration, data storage, and data analysis. 3. Cloud computing. Cloud computing platforms such as Amazon Web Services, AWS, and Microsoft Azure provide cloud-based storage and database services. These platforms allow users to store and manage data in the cloud, providing scalability, flexibility, and accessibility. 4. MongoDB. MongoDB is a popular NoSQL database that allows users to store and manage unstructured data. It provides a flexible schema and a range of tools for data management and analysis. 5. Hadoop. Apache Hadoop is an open-source distributed computing platform that provides tools for storing and processing large-scale data sets. Hadoop is commonly used for big data storage and management. 6. MySQL. MySQL is an open-source relational database management system, RDBMS, that is widely used for web applications and other types of data-driven software. It provides a range of tools for data management, storage, and analysis. These are just some of the many tools and technologies available for data management, storage, and database administration, and the choice of tool depends on the specific needs and goals of the organization or individual. Reporting/visualization: Excel, Power BI, Tableau, MicroStrategy, and others. There are many tools available for reporting and data visualization. Here are some of the most popular ones. 1. Microsoft Excel, one of the most widely used tools for data analysis and reporting. Excel can create charts and graphs for visualization and provide tools for data formatting and presentation. 2. Power BI, a business analytics service provided by Microsoft that allows users to create interactive dashboards and reports. Power BI can connect to a wide range of data sources and provides tools for data visualization and exploration. 3. Tableau, a data visualization software that allows users to create interactive and dynamic visualizations, dashboards, and reports. Tableau can connect to a wide range of data sources and provides tools for data blending and advanced analytics. 4. MicroStrategy, a business intelligence platform that provides tools for reporting, analytics, and data visualization. MicroStrategy can connect to a wide range of data sources and provides tools for data modeling and exploration. 5. QlikView, a business intelligence platform that provides tools for data visualization, analysis, and reporting. QlikView can connect to a wide range of data sources and provides tools for data discovery and exploration. 6. SAP Business Objects, a business intelligence platform that provides tools for reporting, data visualization, and data analysis. SAP Business Objects can connect to a wide range of data sources and provides tools for data modeling and exploration. These are just some of the many tools available for reporting and data visualization, and the choice of tool depends on the specific needs and goals of the organization or individual. Topic 5. Data visualization in Excel. Definition of data visualization. Data visualization is the graphical representation of information and data using visual elements such as charts, graphs, maps, and other types of visual aids. The purpose of data visualization is to help users understand complex data and relationships by presenting them in a visual format that is easy to understand and interpret. Effective data visualization enables users to quickly identify patterns, trends, and outliers, and to make informed decisions based on the insights gained from the data. It is widely used in a variety of fields, including business, science, engineering, education, and journalism, among others. Excel provides several options for data visualization, including charts and graphs, conditional formatting, and sparklines. Here are some of the most common ways to create data visualizations in Excel. 1. Charts and graphs. Excel provides a range of charts and graphs that can be used to visualize data. To create a chart, select the data you want to use, then click on the Insert tab and choose the chart type you want to create. Excel provides a range of chart types, including line charts, column charts, pie charts, and more. You can customize the chart by changing the chart type, adding labels, and adjusting the formatting. 2. Conditional formatting. Conditional formatting allows you to apply formatting to cells based on their value. This can be used to highlight important data or to create heat maps that show patterns in the data. To apply conditional formatting, select the cells you want to format, then click on the Home tab and choose Conditional Formatting. You can choose from a range of formatting options, including color scales, data bars, and icon sets. 3. Sparklines. Sparklines are small charts that can be embedded in a cell to show trends or patterns in the data. To create a sparkline, select the cell where you want to insert the sparkline, then click on the Insert tab and choose Sparklines. You can choose from a range of sparkline types, including line, column, and win-loss sparklines. Overall, Excel provides a range of options for creating data visualizations, and the choice of visualization depends on the type of data you want to show and the message you want to convey. Benefits of data visualization. Data visualization is the process of representing data and information using visual elements such as charts, graphs, and maps. The benefits of data visualization include 1. Improved understanding of data. Data visualization makes it easier to understand large and complex data sets by presenting the information in a clear and concise manner. Visualizations can help users identify patterns, trends, and correlations that may not be immediately apparent in raw data. 2. Better communication. Data visualization is an effective way to communicate data and information to others. Visuals are easier to comprehend than long lists of numbers or written descriptions, making it easier to share insights and findings with stakeholders. 3. Increased engagement. Visualizations are more engaging than plain text or numbers, capturing the attention of the viewer and keeping them interested in the information being presented. 4. Quicker decision-making. Data visualization allows for quick and informed decision-making by providing a clear overview of information. This helps users to make informed decisions more quickly, without having to sift through large amounts of data. 5. Improved data quality. Visualization can help identify errors or inconsistencies in data, allowing for better data quality control and improved accuracy. 6. Better planning and forecasting. Data visualization can help identify trends and patterns that can be used to forecast future outcomes. This can help businesses and organizations to plan for the future more effectively. 7. Increased collaboration. Data visualization can help facilitate collaboration between different teams and departments within an organization. Visualizations provide a common language for discussing data and can help align different perspectives and opinions. Overall, data visualization is a powerful tool for unlocking insights and making data-driven decisions. Types of visualization: comparison, composition, and relationships. Yes, that's correct. There are several types of visualization that are commonly used in data analysis, including 1. Comparison visualization. Comparison visualizations are used to compare two or more sets of data. They are useful for identifying differences and similarities between different groups, categories, or time periods. Some examples of comparison visualizations include bar charts, line graphs, and scatter plots. 2. Composition visualization. Composition visualizations are used to show how a whole is divided into parts. They are useful for illustrating the proportion of each component in a data set. Some examples of composition visualizations include pie charts and stacked bar charts. 3. Relationship visualization. Relationship visualizations are used to show the correlation between two or more variables. They are useful for identifying patterns and trends in data. Some examples of relationship visualizations include scatter plots, heat maps, and network graphs. Other types of visualizations that are commonly used include distribution visualizations, which are used to show the spread of a data set, and temporal visualizations, which are used to show changes in data over time. It's important to choose the right type of visualization for the data you are working with and the insights you want to gain. Qualities of good data visualization. There are several qualities that make a good data visualization, including 1. Clarity. A good data visualization should be clear and easy to understand. It should clearly communicate the message or story that the data is telling, without being overly complex or confusing. 2. Accuracy. A good data visualization should accurately represent the data it is visualizing. It should not misrepresent or manipulate the data in any way. 3. Relevance. a good data visualization should be relevant to the audience it is intended for. It should be designed with the specific audience in mind, and should be tailored to their needs and interests. For simplicity, a good data visualization should be simple and easy to interpret. It should not include unnecessary details or distractions that may detract from the message it is trying to convey. 5. Consistency. A good data visualization should be consistent in its design and presentation. It should use consistent colors, fonts, and visual elements to create a cohesive and professional look. 6. Interactivity. Depending on the context, a good data visualization may include interactive elements that allow users to explore the data in more detail. This can help to engage users and encourage them to interact with the data. 7. Aesthetics. A good data visualization should be visually appealing and aesthetically pleasing. It should be designed with an eye for detail and should use visual elements that are attractive and engaging. However, aesthetics should never take precedence over clarity and accuracy. Overall, a good data visualization should be clear, accurate, relevant, simple, consistent, interactive, and aesthetically pleasing. By following these principles, data visualizations can effectively communicate complex data and insights to a wide range of audiences. Topic 5. Core application of data analytics. Data analytics is a powerful tool that can be applied in many different contexts and industries. Some of the core applications of data analytics include: 1. Business intelligence. Data analytics can be used to help businesses make better decisions by providing insights into customer behavior, sales trends, and operational efficiency. It can also be used to identify new market opportunities and optimize marketing strategies. 2. Healthcare. Data analytics can be used to improve patient outcomes and reduce healthcare costs by analyzing patient data to identify patterns and trends. It can also be used to optimize healthcare delivery and resource allocation. 3. Finance. Data analytics can be used to analyze financial data to identify investment opportunities, reduce risk, and improve financial performance. It can also be used to detect fraud and ensure compliance with regulatory requirements. 4. Marketing. Data analytics can be used to optimize marketing campaigns by analyzing customer data to identify preferences and behaviors. It can also be used to measure the effectiveness of marketing strategies and identify areas for improvement. 5. Sports. Data analytics can be used to improve performance in sports by analyzing player data to identify strengths and weaknesses. It can also be used to optimize game strategies and improve team performance. 6. Social media. Data analytics can be used to analyze social media data to identify trends and sentiment. It can also be used to optimize social media marketing strategies and improve brand awareness. Overall, data analytics can be applied in virtually any industry or context where there is a need to analyze large amounts of data to gain insights and make better decisions. Emerging issues in data analytics. As data analytics continues to grow in importance and complexity, there are several emerging issues that are worth considering. Some of the key issues include: 1. Data privacy and security. As more data is collected and analyzed, there are increasing concerns about data privacy and security. Companies must be careful to protect sensitive data and comply with privacy regulations to maintain consumer trust. 2. Bias and ethics. Data analytics can be biased by the data that is collected and the algorithms that are used. It is important to ensure that data is representative and unbiased, and that algorithms are transparent and fair. There are also ethical concerns around the use of data analytics, particularly in areas like facial recognition and predictive policing. 3. Interpretability and explainability. As data analytics becomes more complex, it can be difficult to interpret and explain the results. It is important to ensure that data analytics is transparent and explainable, particularly in high-stakes areas like healthcare and finance. For talent and skills gap, the field of data analytics is rapidly evolving, and there is a shortage of skilled professionals who can analyze and interpret data. Companies must invest in training and education to develop the necessary skills. 5. Data quality. The accuracy and quality of data is critical to the success of data analytics. Companies must ensure that data is clean, consistent, and accurate in order to generate reliable insights. 6. Regulation and governance. There is a growing need for regulation and governance around data analytics, particularly in areas like healthcare and finance. Companies must comply with regulations and implement effective governance structures to ensure that data analytics is used responsibly and ethically. Overall, data analytics is a powerful tool that has the potential to transform many industries and areas of society. However, it is important to be aware of these emerging issues and address them proactively to ensure that data analytics is used responsibly and ethically. Prepare financial statements, statement of profit of loss, statements of financial position and statements of cash flow for companies and groups. Preparing financial statements for companies and groups involves several steps and requires a thorough understanding of accounting principles and financial reporting standards. The 3 key financial statements that are typically prepared for companies and groups are the statement of profit or loss, also known as the income statement, the statement of financial position, also known as the balance sheet, and the statement of cash flows. Below are the steps involved in preparing these statements. 1. Gather financial data. To prepare the financial statements, you need to collect all relevant financial data, including sales and revenue figures, expenses, assets, liabilities, and equity. This data should be obtained from the company's accounting records, such as the general ledger and trial balance. 2. Prepare the income statement. The income statement summarizes a company's revenues and expenses over a specific period, typically a quarter or a year. To prepare the income statement, you need to subtract the total expenses from the total revenues to arrive at the net income or net loss. 3. Prepare the balance sheet. The balance sheet provides a snapshot of a company's financial position at a specific point in time. To prepare the balance sheet, you need to list all the company's assets, including current and long-term assets, and all liabilities, including current and long-term liabilities. The total assets should equal the total liabilities and equity. 4. Prepare the statement of cash flows. The statement of cash flows summarizes a company's cash inflows and outflows over a specific period, typically a quarter or a year. To prepare the statement of cash flows, you need to categorize all the company's cash transactions as operating, investing, or financing activities. The net cash flow from each activity should be calculated, and the total cash flow for the period should be calculated as the sum of the net cash flows. 5. Review and finalize the financial statements. Once the financial statements have been prepared, they should be reviewed for accuracy and completeness. Any errors or omissions should be corrected, and any necessary adjustments should be made. Once the financial statements are finalized, they can be used for internal and external reporting purposes. It is important to note that the specific format and presentation of financial statements may vary depending on the reporting requirements of the company or group, as well as the accounting standards in the jurisdiction where the company operates. Additionally, the complexity of the financial statements may vary depending on the size and complexity of the company or group. It is recommended to consult with a qualified accountant or financial professional to ensure that the financial statements are prepared in accordance with applicable accounting standards and best practices. Analyze financial statements using ratios. common size statements, trend and cross-section analysis, graph and charts. Financial statement analysis is a crucial tool for evaluating the financial health and performance of a company. There are several methods of analyzing financial statements, including ratios, common size statements, trend and cross-section analysis, and graphs and charts. Ratios are a commonly used method of financial statement analysis, as they provide a quick way to assess a company's financial performance relative to industry standards or historical performance. Some commonly used ratios include liquidity ratios, such as the current ratio and quick ratio, profitability ratios, such as the return on equity and net profit margin, and efficiency ratios, such as the inventory turnover ratio and the asset turnover ratio. Common size statements are another useful tool for financial statement analysis, as they allow for easy comparison of a company's financial performance across time periods or with other companies in the same industry. Common size statements express each line item on a financial statement as a percentage of total assets or revenue, which can help identify areas of strength or weakness in a company's financial performance. Trend analysis involves examining a company's financial performance over time, typically by comparing financial statements from different periods to identify patterns or trends. For example, a company may analyze its revenue growth or its operating expenses as a percentage of revenue over several years to identify areas of improvement or potential concerns. Cross-section analysis involves comparing a company's financial performance with that of other companies in the same industry or sector. This can help identify areas where a company may be underperforming relative to its peers, as well as areas of strength that can be leveraged to gain a competitive advantage. Graphs and charts are useful tools for presenting financial data in a clear and visually appealing way. For example, a company may use a bar graph to compare its revenue growth with that of its competitors, or a line chart to illustrate the trend in its net profit margin over several years. Overall, financial statement analysis is a critical tool for evaluating a company's financial performance and identifying areas of strength or weakness. By using a combination of methods, such as ratios, common size statements, trend and cross-section analysis, and graphs and charts, companies can gain a deeper understanding of their financial health and make more informed decisions about future investments and strategic initiatives. The end. Thanks for listening. Stay tuned for part 2, Practicals. For more information on PDF or Word files, call or WhatsApp Bingwei at 0728 611 828. Don't forget to subscribe to support this channel. Bye bye.